Any presencia black.
Don't share blue.
That's black. We are not there. So before what we are thinking now for one, like just start the literacy. So now I'm going to buy. Remember before. So I wanted to see what is seeing on the screen. Yeah, so now my number is number 2 times 10 to the power minus 5. How is it? Yeah. Then number colors must matter. But the black is very good for this day. Let me see. There's share link on the phone. I want to see.
I sent it to.
Like share link to the phone. I want to see what's the opposite. So I want to see it when because it's the same camera. That's why.
It's just okay.
Okay, yeah. I just want to make sure that it's not opposite from what I can see.
Okay, so good morning. Like I said, we are going to continue from where we ended last time. We're just going to continue revising the test. We're going to start with question 3. So we're going to start with question 3 of the test, question 3C of the test. So the question 3C says we balance the redox reaction under acidic medium. So the reaction was SO4 2 minus plus Br2, which is bromine, to give SO2 or S2 O3 2 minus plus Br3 minus. So that was the question given to us, and we're being asked to balance it in acidic medium. So we know the first step in balancing redox reactions, we have to start by separating them into 2 separate half reactions. So by separating them into 2 separate half reactions, we have to discover which one is being oxidized and which one is being reduced. So in this case, before we even go to that, we're going to have our reactions as SO4 2 minus to give us S2 O3 2 minus. That's one of our first reactions. And then our second reaction was going to be bromine. So bromine, which is Br2, would then produce BrO3 minus. So that's the first step. Like I said, we have to separate them into half reactions. Then thereafter, we're going to balance any other atoms apart from oxygen and hydrogen. So in this case, we have sulfur and bromine. So let's start with the first equation, which is the sulfur. So is our sulfur balanced? Our first equation shows that the S is not balanced. We have 2 at the right-hand side, and then we have 1 sulfur atom at the left-hand side. So we are going to balance it by introducing a 2. Then we come to the second one, which is bromine. We have 2 at the left, so we are going to balance it by introducing a 2 at the right. So we have balanced any other atoms. We have balanced other atoms aside oxygen, and then we are now going to balance oxygen. So to balance the oxygen, we are going to use water. So we're going to start with our first equation. We have 8 oxygen atoms at the left-hand side, and at the right-hand side, we only have 3. So we're going to therefore introduce 5 water molecules to make it 8 oxygen atoms, right? So for the first one, we have 8 at the left, and then we have introduced 5 to make it 8 at the right as well. Then we come to the bromine. Bromine at the bottom has got 3 oxygen, has got 6, sorry. So we have the 2 there, multiplying the 3 there to give us 6 oxygen atoms at the right-hand side. So we're going to introduce 6 water molecules at the left-hand side to balance the oxygen. So remember, firstly, we balance atoms apart from oxygen and hydrogen. Then secondly, we balance the oxygen. Then after balancing the oxygen, the third step is to now balance the hydrogen atoms. So to balance the hydrogen atoms, as you can see, at the left-hand side, we don't have any hydrogen atoms. But at the right-hand side, we have the 10 hydrogen atoms coming from the water molecules. So we are then going to introduce a plus 10 H. So we're going to introduce 10 hydrogen atoms at the left-hand side. We now come to the bottom. At the bottom here, we have 12 hydrogen atoms at our left-hand side coming from the water. So we're equally going to introduce 12 hydrogen atoms from the water. Okay, so since I'm occupying the whole board, I'll just write all the steps on one equation. So from here, we've now balanced the hydrogen atoms. The next thing is to balance the charges. So when it comes to balancing the charges, let's start with the right-hand side. We have a 10 here, we have plus 10 from the hydrogen, and then we have a minus 4. We have a negative 2 there, but remember this negative 2 from the sulfate multiplies the 2 there. So it becomes a negative 4. And then the other side, we only have a negative 2. So these charges must be balanced. So if we have a negative 2 the other side, and then we have a 10, and we have a negative 4 this side, so we'll say 10 minus 4, which will give us 10 minus 4 will give us 6. So we have a total of positive 6 this side. We have a total of positive 6, and then we have a negative 2 the other side. And remember, the charges must be balanced. That's the major reason we're balancing this redox reaction. The charges must be balanced. So to make it balanced, we're going to introduce 8 electrons. So if we have introduce 8 electrons, it's going to be negative 8 plus 10 minus 4, which will give us, so if we say negative 8 minus 10 will give us positive 2, and then positive 2 minus 4 will give us negative 2, meaning we'll have a total of negative 2 charges at the left-hand side, and then at the right-hand side, we'll also have the negative 2 there. So the first equation, therefore, is balanced. We then come to the second equation, balancing the charges of the second equation. Okay, so here we had the bromine, which was that, and then balancing the oxygen, we introduced the 6 there. So balancing the hydrogen inside was supposed to be a 12, a 12H plus. So we balance the hydrogen by introducing 12, balance the hydrogen by introducing 12 atoms of hydrogen, 12 ions of hydrogen, the other side. So the hydrogen is now balanced. So this is the point where we now introduce the charges. So here we have negative 2. And then we also have a positive 12, meaning if we're going to okay. It's still not there? At least. Okay. So since here, this becomes, since here we have a 12, we've introduced 12 hydrogen atoms, and then we already have this negative, and then it multiplies the 2. So we are going to have a total of positive 10, a total of positive 10. But remember, at our left-hand side, we have a 0. We don't have any charge. The total charge is 0. So what we're going to do to balance the charges is introduce 10 electrons. What we're going to do is introduce 10 electrons at the right-hand side to make the charge 0. So we balance the charges. We have 8 there, and we have 10 the other side. So we have 8 electrons there, and then we've also introduced 10 electrons at the right-hand side. So from here, we now balance the electrons for the electrons to cancel out. So I was given marks for, others were multiplying 4 and 5. So I was given marks for any, but the easiest way is just to multiply this by 10, and then multiply this by 8. Okay, so if we want to multiply this, the equation at the bottom becomes so the equation at the bottom becomes 80 plus 100H plus we have the 20 SO4 2 minus to give us 10 S2O3 plus the 10 multiplies that gives us 50.
I can't see what it is.
Okay, let me just write it at the top. So people are saying they can't see. Okay, so we'll have 80 plus 100 plus 20 to give us, we'll have a 10 there. So we have 50 water molecules. And then for the second equation, so for the second equation, when we multiply it by 8, it's going to be 48 So it's going to be 48 water molecules plus 8 bromine to give us 2 BR. Sorry, this becomes 16. So when you multiply the 8 by 2 becomes 16. Then the 8 by 12 becomes okay, so we multiply the 8 by 12 to give us 96 plus 80 electrons. So the electrons are now balanced. So they can easily cancel out. We can now cancel out the spectator ion. So the 80, we'll just write that down there. So we have the 80 electrons cancelling out. So the 80 electrons have cancelled out. We can now look for what else is common. So here we can come to the hydrogen. We have 100 here, and then we have 96 the other side. So this can equally cancel out. So 96 minus 100, we're going to remain with 4 hydrogen ions. So we have 4 hydrogen ions. Then this remains as 20 because it doesn't have anything similar. We now come to the water molecules. So we have 48 here and we have 50 at the right. So this 48 can cancel out with this 50. So if the 48 cancels out with the 50, we're going to remain with 2 water molecules. So we're going to remain with 2 water molecules. Then the next thing, we can then, I think we've cancelled out everything. So we can just rewrite our equation at the bottom now. So we're going to have 4 hydrogen ions plus 8 Br2 to give us, oh sorry, we've left out, we equally have this 20 here plus 20 SO 4 2 minus. Then we also have, this is then going to give us 10 S2 O3 plus, we have 2 water molecules there. And then we also have 16 bromine oxide. So we have 16 BrO3 there. Okay, so as we can see, this is our final answer, but this can be divided by 2. This is divisible by 2. So we can't leave our answer here. Let's take it to its simplest form by dividing everything by 2. So when you divide everything by 2, you discover that our final answer will become 2H plus, then this becomes 4 Br2 plus, when you divide that, it's going to give you 10 SO4 2 minus. And then when you divide that, it's going to be 5 S2O3 plus. So the water will just remain with 1 water molecule, and then we'll have 8 BrO3. So this was how we were supposed to solve such a question. So that's how we're supposed to solve it. Okay. Okay. So now, this was how we're supposed to solve this question. So that's how we're supposed to solve this question. Okay, so the next question, we now come to section B. Now come to section B. Section B, the compound was asking us, the first question of section B, after reading the question, was asking us to find the limiting reagent or the limiting reactant. And we know to say when finding the limiting reactant, we first find the number of moles. So in this case, the equation was given us O3 plus NO to give O2 plus NO2. So looking at this equation, first step, the equation is already balanced. So the equation is already balanced. We have 4 oxygen atoms on the other side, and then we also have 4. And then we also have 1 nitrogen atom on either of the sides. So which compound will be the limiting reactant? To say we not find the limiting reactant, we first find the number of moles. So in this case, we have O3, and then we also have NO. So to find we know the formula to find the number of moles. We just say number of moles is equal to mass over our molar mass. And our mass for O3, which is ozone, in the question was given as 9.40 grams. And then the molar mass, we simply divide the 9.4. The molar mass was, we multiply the 16 by 3, which is 48. Okay, so we multiply the 16 by 3, which will give us 48 grams per mole. And if we were to divide this 9.4 over 9.4 over 448, it was going to give us 0.195 or 0.196 grams, 0.196 moles, sorry. So let me just rewrite it at the top. So we have 0.196 moles. And then for NO, so for NO, we're going to do the same thing. We've been given the mass in the question as 0.767 grams, and then the molar mass for NO is simply 30. So we have 16 for that and 14 for that, which will give us 30 grams per mole. So we have 30 grams per mole. And then after dividing, we're going to find our molar mass as our number of moles as 0.0256 moles. So we have the number of moles of both reactants. We have the number of moles of ozone, which is our first reactant, as 0.196, and then we have the number of moles of NO, which is nitrogen oxide, as nitrogen monoxide as 0.0256. And from here, we can tell which one is our limiting reactant, which is NO, because NO has got the least number of moles. Therefore, NO is our limiting reactant. So we've answered the first part of the question by finding the limiting reactant. So we can now go to the second part of the question. So the second part of the question is asking us how many grams of O2 will be produced. So to find how many grams of O2 will be produced, we know we are going to use the limiting reactant. So our limiting reactant was O3. Going to introduce the concept of mole ratios. So O3 to O2, and our mole ratio is 1:1. So if our mole ratio is 1:1, we know to say the number of moles will be the same. So the number of moles of ozone was found to be 0.025, which would be similar for oxygen. So we have the number of moles of both reactants. So we have the number of moles of our oxygen, which is 0.025 or 0.026. So we can, I forgot, we rounded it off to 26. So we have our number of moles as 0.026 for oxygen. From here, we can easily calculate the mass. So we're going to say mass is equals to number of moles times the molar mass. So the number of moles we just replaced, which is 0.026 moles times the molar mass. So the molar mass of oxygen is 16 plus 16, which is 32 grams per mole. And then after we multiply, it's going to give us 0.819 grams. So we've now calculated the mass of oxygen that will be produced. I hope it's clear. So we've calculated the mass of oxygen which will be produced. But the question is now saying, calculate the mass of excess reagent remaining at the end of the reaction. And then it's also saying, calculate the mass of excess reagent which is remaining at the end of the reaction. So we're calculating the mass of the excess reagent which is remaining at the end of the equation. Okay, so to calculate the mass of the excess reagent remaining at the end of the equation, remember, NO was our limiting reactant, right? NO was our limiting reactant, and we found the number of moles of NO as 0.025. moles. And then the reagent that was in excess was ozone. And then we found the number of moles of ozone as 0.196. So we have the number of moles of ozone, and then we also have the number of moles of NO. So we now want the number of moles. Okay, so let me just indicate the number of moles of ozone okay, just like that. So we have the number of moles of ozone, and then we also have the number of moles of NO. So in this case now, we're going to calculate the mass of the excess reagent remaining. So we know to say this was the reagent that was in excess. Ozone was the reagent that was in excess. And then we had 0.026 as the number of moles of ozone that remained. So we're going to say this ozone, O3, was this amount in excess, 0.195. This was the amount of ozone that was in excess. But of this amount of ozone, that was this was the total amount of ozone that was present. But of this total amount of ozone that was present, only 0.026 moles reacted. So of this, only this reacted. So if only this reacted, we are now going to subtract to find what was remaining. So we're going to say we're going to say unreacted. Okay, we'll put it as unreacted. O3 will be equal to 0.195 moles minus 0.026 moles. So this was the excess of the ozone, and then this was the amount of ozone that reacted. So when we subtract the both of them, we are going to get 0.170 moles. Okay. Okay, so we have the number of moles that unreacted, or the number of moles that was in excess for the ozone, which was O3. From here, we can now easily calculate the mass. So we can easily calculate the mass by saying mass is equal to number of moles by its molar mass. Then we have the number of moles as 0.170 moles. Remember, it's the mass of O3 that did not react because it was in excess. So we're going to say 0.170 times the molar mass of O3, which is 48 grams per mole. Okay, so let me just rewrite it here. So we're going to say mass is equal to number of moles times molar mass. So we're just going to replace our number of moles, which was 0.170 moles times 48 grams per mole to calculate the mass. So after doing our calculations, we'll find that the mass will simply be 8.170 grams. So you find that the mass is 8.170 grams. Okay, so we can now go to the last question, which is question 2. Question 2 of section B. Question 2 of section B. So this video will be here. For those who can't understand, you can simply replay the video because it will be, you can just check for it on YouTube, you'll find it. So you can replay it at your free time and try to understand. And if you have any questions, you're free to contact me and ask. Some of your friends were finding time after the previous tutorial we had on YouTube. They were still making an effort to call me, and I was responding. So you can just text me on WhatsApp, and then when I'm free, I respond to your questions, or you can even call me. Then the next thing was to what reactant is in excess. So what reactant is in excess simply means we calculate the limiting reactant. So from the question is telling us phosphorus burns in oxygen. So in this case, we have phosphorus burning in oxygen to give us, phosphorus burns in oxygen to give P2O5. So phosphorus burns in oxygen to give P2O5. So which reactant is a limiting reactant? So before we even go to that, we know the first step is to start by balancing the equation. So we have a 2 there. We have a 2, so we just simply introduce a 2 the other side. So our P is balanced, but our oxygen is not balanced. We have a 5 there. We have a 5, and then the other side, we equally have a 2. So we can simply say if we balance the oxygen, it's going to be introducing a 2 there, meaning the oxygen will have 10 there, and then we introduce a 5 for oxygen, we equally have 10 this side, meaning the phosphorus again will be tempered with. So we're going to introduce a 4 on the P. Okay. So the equation was balanced. I was given a mark for those that were balancing the equation. I was given a mark for just indicating the balanced equation. Okay. Then the question was asking us to find the limiting reactant. So to find the limiting reactant, we first find the number of moles. So we're going to say number of moles. We're going to start with phosphorus. So number of moles of P is equals to mass over the molar mass. And in this case, we've been given the mass as 10 grams. So we're now going to get the molar mass of phosphorus, which will be 30. We can use 30 grams per mole. So after dividing, we're going to have it must give us 0.3. 0.3 moles. So we found the number of moles of phosphorus. Then from here, say we've been given the molar ratio. And the molar ratio of phosphorus is 4. So we're going to get this 3 and divide it by 4 to get the actual number of moles. So we're going to say 0.3 divided by 4, which will give us 0.081 moles. So we have our number of moles as 0.081. Then we now come to calculating the number of moles of oxygen. So we're going to say number of moles of oxygen is equals to, we use the same formula, the mass over the molar mass. But in this case, we've been given the mass as, in this case, we don't have the mass, so we are going to have to calculate that one. So we're going to say number of moles of oxygen is equals to PV over the RT, which is the pressure in ATM, the volume in liters. We also have the R and the temperature, which is 100 degrees Celsius, and then the temperature is in 100 degrees Celsius, so we're going to convert it to Kelvin, which is going to give us a 373 Kelvin. So what we're just supposed to do here is simply substitute. We're going to put the 0.5263 atm, which is our pressure, then multiply it by the volume, which is given as 30 liters. Then divide it by 0.0821 atm liters, then mole per. Then we also have the temperature, which we're going to take as 373 Kelvin. Then after dividing everything, our final answer was going to be 0.516 moles. So we have our number of moles as 0.516. But remember, from the mole ratios, this is not our final number of moles. We have the mole ratio of 5 there. So we're going to divide this answer by 5. And then if you divide it by 5, it's going to give us 0.103 moles. They've only twisted the question here. Here they're not asking us to find the limiting reactant, but they're asking us to find the reactant that is in excess. So the reactant that will be in excess in this case is going to be oxygen, because it has a larger number of moles, which is 0.103 as compared to the phosphorus, which has 0.081. Okay. So the second part of the question is now asking us to calculate the mass of the excess reactant left. So the mass of the excess reactant left. The concept is similar to the previous question we were solving. So we're going to just write that as the number of moles of phosphorus will be equal to 0.081 moles. And then the number of moles of oxygen, we found it as 0.103 moles. And then they're asking us to find the mass. They're asking us to calculate the mass of the excess reactant that did not react. So the concept is the same. We're just going to subtract the both of them. So we're going to say phosphorus to oxygen. So we introduce them, remember the Molar ratio was 4 to 5. So the mass of phosphorus that reacted, we found was 0.32 323 to X. Then from here we just solve the value for X. So we're going to say NO2 is equals to, we're just going to divide the 0.323 and divide by 4, and then multiply it by 5, which is the 5 there. So to find for X, we're going to find X as 0.404 moles. So this is the number of moles of NO that reacted. Remember, NO, the oxygen, the phosphorus was the limiting reactant. So the phosphorus was the one that was going to guide us to find the number of moles that reacted. So we found the number of moles that reacted as 0.403. The previous question, we were just finding the limiting reactant and the reactant that was in excess. But in this case, we're finding the mass that reacted. So that's why we're going to say 4 to 5. We're going to introduce the Molar ratio and say 4 to 5, and then 0.323 as the number of moles, and then find 4 for X. So we've now found the number of moles of oxygen that reacted. So if we found the number of moles of oxygen that reacted, this is now where I was saying we can simply subtract. So we simply subtract. Remember, we had our total number of moles as 0.516 moles. This was the total number of moles of oxygen. And then we're going to subtract it from the number of moles of oxygen that reacted, which is 0.404 moles. So when we subtract, our final answer must be 0.111. That would be our number of moles, so 0.1112. That would be the number of moles that did not react. But in this case, we're not looking for the number of moles, we're looking for the mass. So after we have the number of moles, we're just going to multiply the number of moles by its molar mass to get the mass. So we have our number of moles as 0.1112 moles. Then we get the mass of oxygen, which is multiply the 16 by 2, which will give us 32 grams. Then we're going to have a 3.58 or 3.58 grams. So that was what we were supposed to do. Okay, so now we can go to the last part of the question. The last part of the question is asking us how many grams of P2O5 will be produced or will be formed. So we're going to do the same thing. Just introduce the concept of Molar ratio. So we're going to have P2O5. The reason we are using phosphorus is because, remember, initially we had said phosphorus is our limiting reactant. Therefore, it's going to determine what amount of product is going to be produced. So the Molar ratio maintains as 4 to 2. So we're going to have our number of moles as 0.32289 to X. So value of X is going to be 0.1614 moles. So we have the number of moles of the product. So we have the number of moles of P2O5 that will be produced. From here, we simply calculate the mass. So we're going to say mass is equal to number of moles by the molar mass. So the number of moles, we just replace it to be 0.1614 0.14 moles multiplied by the molar mass, which is 141.94. Then after multiplying, our final answer must be so our final answer must be 22.19 grams. Okay, so we are done for the test. The next meeting we're going to have is on Thursday, and on Thursday we're going to be discussing the 4th tutorial sheet.
Okay.